Hello, welcome back to the course. We are discussing computer aided design in this week, and also we will discuss computer aided manufacturing in the forthcoming lectures in this week itself. We have discussed something about the SolidWorks software. SolidWorks is one of the very common softwares used by so many people, by students, researchers in actual practice. We have discussed just the part programming in the SolidWorks in the previous lecture. So, in this lecture I would like to discuss the next two modules in the SolidWorks, that is assembly and then drawings. How do we create drawings from the SolidWorks, from the components or the assemblies that we have made. So, this is the software platform here. We have discussed regarding the part programming. So, let us try to see how do we assemble now. So, starting with this is the basic window. So, let me click on home once again. So, this is the basic window of the SolidWorks for the part, and we know that we can select multiple planes here. So, I will just what I will do, I have selected part again, and I am gonna make a complete assembly. Which assembly I am gonna make, I will just show you. This is the assembly that we are gonna make. What is this? This is a flange coupling. This is a flange coupling in which we have two flanges, and it is coupled using nut and bolt assembly. We will make each thing here, nut, bolt, we will see how to color them, and we will see how to see the different views of this. This I will start from scratch. The previous video what we had just crude information on that, what are the commands, what are the major operations in SolidWorks. In this we will make this coupling. So, I have just fixed some dimension for the shaft and for the flanges and for the nuts and bolts. So, I will move accordingly. So, let me start from the part. So, I am coming to part here. Okay. So, it is opening now. So, basic window starting. So, you have seen that it's seen this in the previous lecture. So, this is the platform. Now, I need to select a plane again. Immediately I will make components for the flange coupling. Flange coupling is used to connect two shafts which are concentric. So, we need two flanges which are identical. So, let me consider the shaft dia is 20 mm. So, I will do accordingly. The 20 mm dia shaft has to be fixed using this flange coupling. So, for making the flange, first I will start from the circle. This is a circle. Radius of the circle, first I will put the outer radius. I will put radius as 40 because the dia is 80 millimeters here. So, let me extrude that because this is just the flange. So, I accept this. So, now extruded boss. So, I will put 10 mm. Okay. So, now this is the flange. So, now I need to cut extrude here to make a hole inside it. So, we can select this and make it perpendicular. We have made this face perpendicular. So, this standard dimension here is 40, for the half of 40 is 20. So, I will put value 20 here. So, we need to extrude this. Okay, let me extrude up to 40 mm. So, this is the extrusion part, extruded part, the inner side. So, this is extruded now. So, now we will do a through hole in it. So, a roll has to be drilled here. For that I need to know the shaft dia. So, shaft dia, let me put some circle here. So, shaft dia here is 20 millimeters. So, 10 mm would be my radius. So, I will make an extruded cut here. So, it has to be through. So, we can just extend the arrow or we can just put a through hole. Both the ways could work. So, through hole, that is all, through all. Okay. Accept. This is a shaft diameter that is made now here. So now we need to drill hole here for the nut and bolt system. So nut and bolts should be perpendicular to the axis here. So diameter for the hole is 8 mm. So for 8 mm dia, I put 4 mm as radius. Now smart dimensioning is one of the operations that I will show you. A smart dimension is to put the dimension in a proper location. So I need to put this in the center of this. So this is, I will put value 30 mm here, 30 mm distance from center. So this is smart dimensioning. So this is exactly 30 mm from the center, that is in the center of the flanged part of the coupling. Now I need to put 4 holes. I will put linear sketch pattern here. So simply linear pattern I can put just 4 is already selected. Okay, 4 copies. So all the dimensions are same. It is already 360 degree. Total number of holes are 4. So each separated by 90 degree. So I will just accept this. Now this hole is made. Now again extruded cut command to make a through hole. So extruded cut. Okay, all the 4 holes are selected in one go and extruded cut command is applied. Now we have got holes. Now this is the flange that is ready. Now it is almost ready, but only things that we need to take care of now is the fillet part to make the corners smooth here, the edges smooth here. So constant side, various size fillet, again the fillets that we have discussed before are here, the full down fillet. So let me put it constant size fillet here. So the radius for the fillet here is, I will put 5 mm, and I can visualize that how does this 5 mm looks like. If it looks large, we can decrease it or we can change accordingly. Okay, I will put 2 mm. Okay, 2 mm looks better. So 2 mm. Okay, Control S or saving it. Control S, it is saving. I will name the part as flange. Okay, this is flange. This is one of the components. So this is ready. Now again one more part. I need to create bolt and nut. Let me first select bolt to be made here. I will select a plane, front plane here. I will select circle. For bolt, I think let me start from the head only. The head for the bolt is hexagonal. I am selecting hexagonal bolt. So a hexagon here. So a random size is selected. Let me put the dimensions here. So this is okay. This is width across the edges. Width across edges is actually 1.5 D plus 3 mm. So my D here is 8 mm. 8 mm hole is there on the flange. I am going to put some value here. So that value 16 is selected. Also I am making a little. So I am making a little changes. I am selecting my own dimension. However, the width across corners has to be 2D. I am putting 2D for width across the edges. So this is a customized bolt that I am making here, not a standard bolt. Okay. Then I can extrude this hexagon. Okay, let me make the head of the bolt as 5 mm thick. So this bolt is there, bolt head is there. So we can just decrease from here itself. Okay, let me make it 5. Okay, 5 looked a little smaller, so let me change it to some value, maybe 7. 7 looks okay. Okay, so this looks like the head of the bolt. Top of the bolt head is to be still made. Now I will select a circle. I selected a circle. I am trying to align it with the with the edges of the hexagon here. So, now here also I need to select them simultaneously. I will select this and this control. Now, there is a command here, there is a relation here, tangent. If I click tangent, it will bring the circle close to the edges and make the edges as tangent to the circle. Now, you can see here. Now, what we can do, because the corners of the head are filleted, it is better, I would say fillet would not apply well here, it is actually drafted here. So, draft command I did not discuss. Draft command is something like making an edge slant. For instance, this is completely rectangular body. So, if I need to draft it, I can put some angle here. So, this body might become something like this. So, this is draft command. If I say this line, this is the draft command. So, body would have, suppose if let me say this thickness is 30 mm, if I need to put or need to have 20 mm on this side and 30 mm on this side, it will have some taper in it, that is draft command. This could be applied to circular surfaces as well. That draft operation I will just apply here. So, how do we do this? So, I just need to flip the other side and I will try to make a draft here. So, you see a 60-degree draft is made. The corners are now a little are brought to a 60-degree angle that has smoothened the top surface of the bolt. So, next I am trying to make the threaded part of the bolt. I will not make threads, but just the representation. So, the hole size is 8 mm. So, I need to put, I have selected this circle of 8 mm size. So, let me say okay 80 mm bolt. I have made it a little 80 mm is too big, 8 mm is 60 mm, 60 mm also is a little big as well. So, I will might change it when I go to the assembly. I will see, I will show you that while assembling as well, we can change the component dimensions or component properties, and that would change all the components. So, we can put some fillet here around the circumference of this extruded part. So, I will name this part as bolt. Okay, bolt is saved now. So, similarly, I will select a new part. New part I am going to make is a nut. So, sketch, first I select plane, normal to the plane, then circle, okay, hexagon first. So, again same size 60, then this is 2D, this is 16, this is 16, twice the dimension, the customized bolt selected. Okay, applied. So, let me extrude it, this is extruded to size 10 is a little smaller, 5 would be lower, I can put 8 mm is okay. So, this is the, I would say, base for my nut. I need to now put again the similar operations. I put circle here because I need to put some draft over it. So, again the smart dimension, this to this. So, better I do it in a way to make it tangent, this circle and hexagon tangent, that this has worked now. So, again a 60-degree draft has to be put. I do the extrude cut, flip side to cut 60 degrees. It is actually draft is being applied here using a extrude cut. So, now this feature is almost ready. Okay, in this side I need to put hole now here. Okay, this hole size is 8 mm, diameter is 4 mm radius. I need to cut extrude this as well. So, I am not focusing on threads at all. I have just made a hole that is to be fitted here. So, I will save this part as nut. Okay, now the 3 components are ready. Now, I am going to assembly now. So, this is the final assembly that I need to make. In this we can see we need 2 flanges, 4 nuts and 4 bolts. So, to make them, let me start with my assembly part. So, I have made nut, bolt and flange. So, now I will again open a new file. I will open assembly here, assembly. Okay, when I click assembly, it is showing the components, those are there. Flange is one of the components here, the 3 components here. We can also browse the components from here. 3 components already we have made, put in one document, put in one folder here. So, I will first select flange from here. So, as we need to make 2 flanges, so we know that, and we need to assemble them as well. So, this is the flange that we have made. So, the second flange can again be inserted while again opening the part list and clicking on them, assembly. So, I will again insert a component, insert component from here, again a flange. Okay, the flange has come now. Now, these components to be mated, and the one of the flanges is to be flipped over. So, as we know that when we have to do mating, the holes have to be coincided. So, I will just mate the holes. So, I will mate this hole with this hole. Okay. Now, this is mated again, please see. Again I am going to mate command, I am making this hole concentric with this hole. So, this has gone concentric now. So, I have flipped it over. See, there is certain options here. See, there are certain options here. I need to flip it over. To flip it over, see lock rotation, I have flipped it over. Now, the holes axes are coincided, and they are now concentric circles. So, concentric, they are coincident, parallel, perpendicular, tangent, concentric, we can lock rotation. So, there are certain ways. So, on this circle, this concentric, this circle and this circle I need to make concentric. Okay, done. Now, this is accepted. So, again this face has to be mated with this face. When I say this has to be mated, it has to come closer. So, in this case, now these are in the same direction. Now, I have to stick the faces of the flanges. This face is the face of the other flange. I will again put mate. I will put select this surface is to be mated with this surface. So, the mate has happened. So, now the flange setup is ready. So, it is mated. Now, I need to insert components again. I need to insert nut and bolt. So, I will insert nut here and I will insert bolt as insert component bolt. So, this bolt looks a little larger, the length of the bolt is a little larger. So, now while working as well here in the assembly, we can change the dimensions for the bolt as well. So, these components are here, this component, this is the component bolt. I will change this dimension. So, this dimension I am just making it maybe 30, close to 30 mm or so, this should be okay. So, again I am opening the assembly part. In the assembly, okay, now it looks too good. So, again mate, we have to mate this circle, this hole with this shaft. This is brought concentric, till now it is just made concentric. So, axis it has come into one line, second mate command is between the surfaces. So, we have to coincident the faces, this face and this face. Yes, now it is gone in. This is known as mating. Now, this is done. Now that nut is to be put on the other side. The similar command is used here. I will just put this circle and this circle. Okay. Yes, now this is interesting. Now, where has nut gone? It is mated. This is important to note, since we cannot see the nut here. So, we need to either bring wire mesh or we need to make something transparent to see the nut. So, we can hide the flanges or we can make them transparent. I will go to flange here, flange properties, change transparency. If I go to change transparency here, it is changed the transparency. Now, we can see the nut inside. For the second flange as well, I have changed the transparency. Now, the transparency is being changed, it is just showing the edges here. So, we can see the nut, because nothing is still locked, we can easily move the nut. Okay. So, we can move it. It was not locked, it was not mated, the surface were not mate. Again mate this thing, the surface mate with this. Now, it is ready. Now, this assembly with one of the nuts and bolts is ready. Okay, this has now one nut and bolt and the flanges. Now, I need to create 4 copies of this, 3 copies of this to make it 4 nuts and bolts. One of the ways is to insert components separately from the parts components that we have, like we did it in flange. The another way is to make the pattern, because we know there is the 4 nuts and bolts in the 360-degree rotation here. So, that same thing we can apply here. We will make the copies that those are there in the parameters. We need to just rotate it. We will make 4 copies of this pattern. Spacing I will put 90 degree along what I will put equal spacing. In 360 degree it is better. So, yes, 360 degree equal spacing. Now, yeah, bolts are copied or a pattern of bolt is created. I will accept it. Oh, I did not select the nut along. Similarly, we can do the nut. We could have done it together. So, again a circular pattern for the nut. Okay, delete this pattern, this nut. Again, this is the parameter face or flange, 4 copies. Yes, it is okay. Click here and select. Now, this coupling is complete. I did not consider the threading part, I did not consider the key. There is actually in a coupling to fix the shaft, there is also key in the shaft that is also there with the coupling, so that the shaft is locked with the coupling with the flange. So, those I am not putting it right now. So, just consider that this is the assembly, just a basic introduction to how does assembly happens in SolidWorks. So, let us now try to see the different views here. So, this is zoom to fit. If I click this, it will fit it best to the screen. Zoom to area, I can just select the whole area, I can select a small area, I can zoom it in. Suppose if I need to select this area, this will zoom it to this area. Then next is previous. If I click there, it will just show the previous view. Previous view was the zoom to fit. So, this section view, this will show the section at any plane that we need to see. Also, we can rotate this to see the section at any angle if we need. It will show the section along this plane. Okay, I can just make it back and forth, and also rotate this to see the section view. So, this is just how do we like to have the output of our file. So, this is the section view. So, this is 3 dimensional 3 views that we need to see, which we would like to see there. So, suppose we just need to see this, we can click this. So, this box appears. So, suppose if we want to see this, we can easily get this these options. So, this is a shortcut of getting the views. So, you can see, so isometric view is here. Okay. You can directly see from here, you can see any face here, so many ways there. So, this is generally viewed in isometric. This is isometric view in which we have all the views, top, right and left. So, also we can change the edges, we can change the view solidity, I would say. Now, I have removed all the edges. So, edges are disappeared from here. Also, we can see only hidden lines removed and only the edges. So, this is one of the views that is prominently used in industry. Yes, we can also show the hidden lines. You can see the hidden lines at the back. Hidden lines, the dotted lines are also being visualized here. Also, okay, this is mesh. This is wireframe. Wireframe is a little difficult to understand. Generally, it is not shown, but sometimes the continuity requirement just to see whether what are the various internal components, internal lines or drawings or dimensions. Sometimes it is also shown. Also, yeah, these are also the shortcuts that we had been using, the view plane, view angles, coordinate systems, view planes, the various shortcuts that we have been using here as well. These shortcuts are there directly placed here. So, these are also a few views. We can put grid at the back, we can view coordinate systems, we can view axes, view planes, then view lights as well, we can see shadows and lights. So, this is, so part design the options were different, for assembly the options are different. Okay, what test is this? This is regarding edit appearance. Edit appearance, this is just about appearances. If we know the material of the components, I can just change the appearance accordingly. Suppose the component is made of mild steel, aluminum, magnesium, copper, gold. These all metals have different colors. I can, okay, for steel I can select polished steel. If I select polished steel, it will show it like a polished steel. Okay, this is a polished steel that is showing here. So, also we can change the chromatic value here. This is just a appearance, say RGB value. So, also we can change the background like plain white backdrop, soft spotlight, rooftop, and country courtyard, urban background. So, these options are also there. You can just keep trying these commands separately and keep learning how those things happen if you wish to work in CAD. So, this whole assembly is now selected and I am selecting polished aluminum. It is showing the appearance like a polished aluminum surface. And magnesium. Okay, let me change the color, gold. Okay, now this is gold, it is showing the gold color here. These are certain ways to represent or to show different kind of the components. We can just keep coloring them. Okay, let me first save it. Okay, assembly format. In the assembly format, we have the assembly format, it is ASM. Then we have the, so IGS. Okay, this is IGS, when we want to change from one computer to other. STL is standard tessellation. So, this is used for 3D printing. IGES is graphic exchange format, CATIA, ProE, when different softwares are there, Adobe Photoshop, JPEG images can be made. So, SolidWorks provides us a great variety of storing facilities, storing options here. I will just name this assembly as Flange assembly and save it. So, this is the assembly that is ready now. for the appearance, for instance, there are certain complex components, different components in which we have, I would say, different assemblies are there where the components are there we need to see. So, this can be used, this coloring pattern can be used when we have a big assembly components and different parts, those are meeting, we can show the components or parts with different colors. For instance, if there are different kinds of bolts, different sizes of bolts, we can show all the bolts of 5 mm or so with green color, all the bolts of 10 mm with a light green color, the components which are made of different materials, steel, copper, like gray color for steel, then a little brownish color for copper, that can be shown. So, these all options are already there, but the major part in computer aided design is engineering. So, softwares, as I keep telling, softwares are GIGO, garbage in, garbage out. It is all the intelligence or the understanding of the operator or the CAD designer who is putting the data in. The proper data if you put in will get the right output. Also, we can do certain simulations on software itself. We can do stress analysis, thermal analysis before taking the part to the actual manufacturing. Those things are also possible. So, we will continue our lecture on computer integrated manufacturing. See you in the next lecture. Thank you.